In our discussion of quartiles, we listed 5 values from a data set. Those values were the minimum value, and then we found Q1, and we found the median, which also is called Q2, then Q3, and then the maximum value. So these values from a data set describe that data set, and they're a special group of numbers called the 5-number summary. A box plot is a graph that uses this 5-number summary to display the data and give us a visual representation of the data. So let's look at an example. Okay, so here we have a data set. Let's see, and how many in our data set? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So our sample size here is 17. They're not in order, but what we're going to do, as I mentioned before, is we need these Q1, Q2, Q3, or Q1 median Q3, and there's no universal agreement on how those should be calculated. So to keep us all on the same page, we're going to use our TI 8384 technology. So we really don't have to get these in order to find that 25th percentile, 50th percentile, and 75th percentile that our Q1 median and Q3 represent. We will use our technology, and we don't have to have it in order to do that. Okay, so here's a representation of your calculator. Let's move it over just a little bit, and let me show you how we're going to enter this data in the calculator. So we'll turn it on, and to begin, we use the Stat button, Stat, and what we want to do first is edit. We want to enter a list, and that's edit. So we've highlighted edit at the top, and the first thing, number 1, is edit. So we'll enter, and in list 1 we want to list our data. The first value is 14, and so after each value I enter, notice down here it's saying list 1, number 1, the first data value in list 1. Enter, and then it drops down to still list 1, now number 2, and for us that value is 6. Enter, and then 3 and 2 and 4, then 15, 11, 8, 3, 7, 2, 1, 1, 4, 10, 22, and 20. Now we said we had 17 values. It's not a bad idea to take a moment and check here to be sure we didn't skip over anything or duplicate. And what I see, it's anticipating that I'm going to put in the 18th value here, but we don't have 18, so that means I have entered 17, so that's good. Okay, so now we want to calculate our 5-number summary, so we'll go back to Stat, and now we want to tab over to Calculate, and we do want this first selection here, 1 variable statistics. Enter. Now it wants to know which list I put my data in, and it's initiating at list 1. That is where my data is, so I don't need to change that. I have not put any frequencies in a separate list, so I'll just skip over that and go to Calculate. When Calculate is highlighted, I hit Enter. Okay, these are the 1 variable statistics from my data set, and what we're looking for here is our 5-number summary. Notice the arrow is saying there's more information. See, I don't see my 5-number summary there, so I'm going to tab down, and here we're seeing now the minimum X, Q1, the median, Q3, and the maximum X value. So let's record those over here. Whoops. Sorry. Okay. The minimum, Minimum was 1, and the max Q1 is 2.5, median is 6, Q3 is 12.5, maximum is 22. So now let's just record those. So our minimum is 1, Q1 was 2.5, our median was 6. Whoops, I didn't write Q1, did I? Q3 was 12.5, and our maximum value was 22. Okay, so now we're ready to create our box plot. In order to do that, we need a scale. We need a number line. So I'm going to draw a number line here. I know my minimum value is 1, my maximum is 22. Okay, so I'm going to let this represent, let's say, this will be 1, and this will be, let's go to 25, and then see if I can break this up into 5 groups just to give me a scale here. So 1, 2, 3, 4. Okay, if these are by 5s, then that's 1, and this would be 5, 10, 15, 20, and 25. So it's kind of a rough scale, but it's going to help me stay keep my values relative to each other when I draw the box plot. Okay, so the lowest value is noted with a just a point. So my lowest value here is at 1, and the box is actually created using the quartiles. So Q1 is 2.5, so that would actually be halfway between 1 and 5. So Q1 is going to be about right here. I'm just going to put a dot for now. The median is at 6, so that would be right here, just past the 5. And Q3 at 12.5, which would be right between 10 and 15. I'm putting these kind of in a line here just to keep it this straight. And then my maximum is 22, so not quite halfway between 20 and 25. And that's a dot. Okay, so we're going to actually construct a box here using Q1, as best I can draw here, to my Q3. This is where it gets the name Boxplot. Recall that measure the interquartile range. That's what the box represents, because this value right here is our Q3, and here was our Q1. So the width of that box gives us a feel for the interquartile range. And then at the median, we just draw a line in the box. So there's our median. So the median was 6, Q3 was 12.5, Q1 was 2.5, and our minimum value was 1, and what we draw here is just a straight line. Sometimes this is called a box and whiskers plot because these look like whiskers coming off of the box, and then a line out to our maximum value at 22. Okay, so this is what we call a box plot, and it gives us a feel for not only do we get our 5-number summary, but we get a feel for the distribution of the data, how the data is clustered together. See, the median, of course, represents the value in which 50% of the values are lower than that number. 50% of the values in this data set are less than 6, and 50% here are higher than that number. So we can see that most of the data is clustered here. This is kind of that, if we were thinking back to our skewness, then most of our data is here. We would peak and then we drop off. We have a long right tail there. So this is right skewed data. We can tell by looking at the box plot. We can get a feel for the IQR. The IQR interquartile range, which is of course Q3 minus Q1. We can calculate that. 12.5 minus 2.5 and get 10, but we also have a visual of how that 10 looks relative to the rest of the data. So what's important here, number one, is you have to have some kind of scale. You can't just arbitrarily draw this and make the distances anything you want them to be. You need some sort of scale, even if it's your best guess, as I did here. But you have to have some sort of scale that the box is on. Now these are also handy if I had more data, another set of data, and I wanted to compare. I could leave my scale here and then draw maybe above this one the second set of data, and then it'd be easy to compare the differences in the medians and the IQRs and the highest value and the lowest value and the shape of the data. And so that's another great way to use box plots to compare sets of data. So that's an example of a box plot. They're easily constructed, as you saw, and use these very important numbers, that 5-number summary. They give us so much information about a data set. The last thing I want to do here is to emphasize the connection between our original data and the 5-number summary. And this is best done by putting the data in order. So let's do that. We didn't have to do that initially because we did use the computer technology, but now let's do that and see what that connection is. So we had a 1, a 2, another 2, 3, 3, 4, 4, 6, 7, 8, 10, then 11, 14, 15, and then we had that 20, and 22. Okay, so clearly our minimum and maximum are obvious here. So here's our minimum, that makes sense, and our maximum. Minimum was 1. This is what the calculator told us. We didn't have to seek these out and look through the data set because we put them in any order, and the calculator gave us that. Minimum was 1, maximum is 22. Then it gave us the Q1, median, and Q3. Let's look at the median. So we said that that's the middle value in an ordered data set. This is an ordered data set. It happens to be an odd number of values. Our n was 17. So that means it's actually the value right in the middle. Since we have an odd number, they're going to be an equal number below and above that number. So let's see. This is the 1, 2, 3, 4, 5, 6, 7, 8. And so the 9th value would be our median because there are 8 values below 6 and 8 values above 6. So this is our median. Okay, and so now we can think about that the Q1, Q3, and we've got our median, and we separate the data into fourths, in each one being 25% of the data. So here we have these 4 values and these 4 values, and so that's the break. Here is where our Q1 would be. Okay, so we have about 25% of the data is lower and than this value right here. So notice I did say that calculating these quartiles, there's not a universal way to do it, but what we can see what the calculator did here, it took the average of 2 and 3 to give us that 2.5. And then above 6, got these 4 and these 4, and here is our Q3. And again, we can tell that the calculator added 11 and 14 and averaged those, divided by 2, and got 12.5. So I just wanted to take a minute and let you see how that data is actually being organized and where we're finding those quartiles in the data set. Okay, I need to make a correction here. When I drew that number line showing for my data and breaking it up into quartiles, I started with a 1 here, but this should be a 0. I had 1, 5, 10, 15, 20, and 25, but that first should be a 0. 1 was my minimum value, and I had that sort of stuck in my head. So make that correction on your number line. This number here should be a 0. And one other thing, when I was talking about the median, let me say this again, how I would prefer to say this, that it's better to say that 50% of the data is below this value. I believe I also added 50% above, but really we think of the median as the value in which 50% of the data is below that value. Okay, so continuing with the problem we were working, we want to know if any of our data has any outliers. So outliers are values above Q3 plus 1.5 times the IQR, or below Q1 minus 1.5 times the IQR. And recall that the IQR, that's the interquartile range. So it's the difference between Q3 and Q1. And in our problem, Q3 was 12.5 and Q1 was 2.5. So the IQR would be 10. Okay, so let's find out what the cutoff points are for our outliers. So we would say above Q3, which is 12.5, plus 1.5 times 10, or 12.5 plus 15, which would be 27.5. So anything above that would be considered to be an outlier. And then below our Q1, which was 2.5, minus 1.5 times 10, or 2.5 minus 15, which is negative 12.5. Now, oftentimes it's impossible to get a negative value in your data, just depending on what you're counting. If these are home runs, there wouldn't be a negative number, of course. But it's okay, that's what our value is. So in other words, it's not possible to have an outlier in the low end, but it certainly is possible to have an outlier in the upper end. So now looking back at our data, we had a maximum value of 22 and a minimum value of 1. So anything above 27.5 would be an outlier. Well, our maximum is 22. We do not have anything above. And as we said, with this negative value here, there's essentially no way in a data set that can't have negative numbers to have a outlier in the low end. And our minimum was 1. So that we would say this data set has no outliers.